In this video, we are going to learn some elementary concepts of geometry. Of course, you would have learnt it in your earlier classes. This is just to recall all these concepts so that we can apply it in a further geometry. So, consider this as an introductory video to geometry. Now, all of us have learnt about a number line. In fact, we've been learning even in our earlier real number line chapter. So, this is a number line. The only thing is that it extends on both sides. There is no initial point nor an end point. That is, we say that they extend up to infinity on both sides. So, this is exactly what a line is. We do not know the starting point, we do not know the end point. Now, if you take a portion of this line and redraw it, that is, we are aware of the initial point, we are aware of the end point. This is called a line segment. You can measure this. I am naming this point as A and the end point as B. So, AB, line AB is called a line segment, and it can be measured in any unit, meter, centimeter, whatever. Now, suppose you know just the initial line, the initial point A, and if the line extends up to infinity, you do not know the end point, we call this a ray. This is said to be a ray. You would have learnt about rays in physics. So, this has a starting point, but it does not have an end point. So, when two rays start from the same starting point, say from here, this is one ray and another ray. So, an angle is formed, isn't it? An angle is formed in between the two rays. So, if I call this starting point as O and this is ray A and ray B, an angle AOB is formed between the two rays. And how are angles measured? Angles cannot be measured like you measure lines, because how much farther away one ray is from the other differs from point to point. At this point it's so much, at this point it is more. So, we cannot measure it in the normal units which we have been using for measuring length. So, we need some other unit for measuring angles, and this unit is degrees. As of now, we measure angles in degrees. Now, what is a degree? How is a degree defined? So, we will have to go to a full circle in order to look at the definition of a degree. So, this is a circle, and the angle around the center of the circle is said to be this angle. A full revolution, a complete circle, a full revolution around the point is 360 degrees. This is the definition of degrees. And if the 360 degrees is divided into 360 parts, you have 1 degree. So, if this is equal to 1 by 360, this is 1 degree, 2 degree, and so on. So, what happens if there is half a revolution? Now, it's a complete revolution, we say it's 360 degrees. What happens when it's half a revolution? That is, this is one ray. It starts here and it goes on and ends here. It forms a straight line, isn't it? Of course, we call it the diameter of a circle, but here we are learning about degrees. So, it forms a straight line. So, what is half a revolution? Half a revolution is 360 by 2, 180. So, this is 180 degrees. This measure in a straight line. So, we say that angle in a straight line is equal to 180 degrees, right? Or it's also called as a straight angle. This is also said to be a straight angle. So, angle in a straight line is 180 degrees is all what we should remember from here. And what about 1/4 of a revolution? That is, the ray begins here, it revolves and, let me draw it again. So, this is 1/4 of a revolution. The angle formed would be 360 by 4, which is 90 degrees. We also call this 90 degree angle as a right angle, isn't it? So, you would be recalling this, that it's called as a right angle and the lines are said to be perpendicular to one another. So I'm just trying to revise these terms for you. The lines are said to be perpendicular to one another. Now, having seen lines, line segments, rays, and angle in a circle or 360 degrees, and having learnt about degrees, now let's see what happens when two lines intersect. Let's have two lines like this. They intersect one another at a particular point. If I call this point as O and this is line AB, this is line AB and this is line CD, right? They are intersecting at O. Now we are concerned about the angle which it makes at O. The angle which line AB and line CD make at O, in fact they make 4 angles at O. If you call this angle 1, angle 2, angle 3 and angle 4. Is there any relationship between these angles? This is what we are going to explore now. Now we know that angle in a straight line is 180 degrees. So if you consider the line AB, at O it makes 180 degrees, isn't it? The line AB here at O, it makes 180 degrees. That is angle 2 plus angle 3. The sum of the measures of these two angles, angle 2 plus angle 3, should be equal to 180 degrees because they are angles in a straight line. Alright. Similarly, if you look at angles at CD, the angles which is made at the point O by this line CD will also be equal to 180 degrees. So what are those angles here? This is CD and this is O. So you have angle 2 plus angle 1, right, is also equal to 180 degrees. So now we have two equations. Let me call this equation number 1, let me call this equation number 2. I see that the right hand side of the two equations are the same 180 degrees. So it is fair that I can equate the left hand sides also. That is, I can say angle 2 plus angle 3 would be equal to angle 2 plus angle 1, right? And both of them are of course equal to 180 degrees, but our concern is not that now. Our concern is angle 2 plus angle 3 is equal to angle 2 plus angle 1. Now what can you infer from this? Here angle 2 and angle 2 are the same. The measure is the same. We are talking about the same angle. So what if I subtract that measure from both sides of the equation? This is minus angle 2. Here also in the other side also I am subtracting angle 2. So as a result I would be getting angle 3 is equal to angle 1, right? Or this angle 3 would be equal to angle 1. Now I suggest that you work on these similar terms and arrive at this angle 2. Arrive at angle 2 is equal to angle 4. I think you can easily do that. I give it to you as a work to do on your own. Arrive at this result, angle 2 is equal to angle 4, and hence we can conclude that when two straight lines intersect with one another, the opposite angles, they are also called vertically opposite angles. The angles when two straight lines intersect with one another are called vertically opposite angles. So we can conclude that the vertically opposite angles, angle 3 is equal to angle 1 and angle 2 is equal to angle 4. So this is a major property which would be used in our further geometry. That is why I am stressing on this point. So the vertically opposite angles are equal when two lines intersect with one another. So I hope you understand this point. Now in our next video, we are going to see what happens when the lines do not intersect with one another. Now we have talked about lines intersecting with one another. What happens when lines do not intersect at all with one another? Now look at these ruled lines in this paper here. So this is one line and this is another. Obviously, they are not going to intersect anywhere. How much ever you extend the lines, to both sides. They are not going to intersect anywhere, and the distance between these two lines are going to remain the same. This distance is going to remain the same wherever. So these are called parallel lines. The lines which do not intersect at all and which are equidistant from one another are called parallel lines. In our next video, we are going to look at some properties of parallel lines. Till then, thank you.